Hello, class. This video is going to help with 11.3. I almost said 4.3, but it is 11.3 in the book we're in right now. And this is over La Hopitals rule. Let me write that down real quick. It's L' Hopitals. So we've been talking about that first derivative, that second derivative, and what they do with the graph. And then this one is kind of a little bit different. So it's going a different direction a little. What this is it tells us we can actually take the derivative to find the limit. So we couldn't do this before because we didn't know how to do the derivatives. So here's what I'm talking about. So this is for used for indeterminate forms. And remember, that's where we have the 0 over a 0 or an infinity over an infinity. Okay, so it's the 0 over 0. I don't even know if we've done any with the infinities. Anyway, so if we're doing a limit and we get that 0 over 0, this is a new method for that. Instead of, we had factoring and rationalizing the numerator. And rationalizing the numerator was a huge pain. I didn't even put it on your exam because it was such a long process. So this one reads, if the limit as x approaches some kind of number, c, and the function equals 0, and the limit as x approaches some kind of c of a second function equals 0, then the following is true. Then the limit as x approaches c of f over g, so we basically are defining that it was a 0 over 0, is going to equal the limit as x approaches c of the derivative of the function over the derivative of the function. So we can do the derivative of the top and the bottom, then put the number in when we have that 0, 0 form instead of factoring. And this could be a lot quicker process than any of the ones we did before. So let me give you some examples. All right, so my first example, what if I'm asked the limit as x approaches 4 of x squared minus 16 over x minus 4? Now, I'm 90% sure this was on the test, but it could have been a 5 and a 25. It was something similar. It could have been a 4 and a 2. Anyway, so if I right now put in my value 4, then we will have 0 over 0. So we have to check that first. And we can see we are in the 0 over 0 form. So check that, and we are. I mean, that's the whole idea of this idea here. So what we can do then is take the derivative of the top and bottom, and we're still keeping this limit. So the derivative of the top is going to be 2x, and then the 16 goes to 0. The derivative of the bottom is the 1 for the x, and then the 4 goes away. So now we have just 2x, and then we can put that value in. So we'd have 2 times 4, and so we end up equaling 8. So the limit as you approach 4 is 8. So it's going to 8. Right? So if we graphed it, where's it going? To 8. Okay, at 4. All right, let's look at a harder one. That one's not really that hard. I was like, nah, we want a harder one. Let's do one that's in this form. So let's do limit as x approaches infinity of 5x plus 4 over 6x plus 9. Now, these are the ones that I was saying I don't think we did a lot. a lot of them in the homework. It just, because we needed to learn the derivative to be able to do some of these. So what is this saying? It's saying put in infinity, and you have infinity times 5 over infinity times 6. That means you're constantly going to be growing, and that means you're going to infinity over infinity. So this one's in the form infinity over infinity. And I should always say you could have negative infinity over a negative infinity as well, and it would be in that form. So we are in that form right now. Most of you are probably like, well, the answer is 5, 6. I know, it is. But it really is infinity over infinity. But you're timesing that number by 5 and timesing it by 6. So it's basically going to 5, 6 because the values are the same. But we could use this new idea. So the limit as x approaches infinity. I know we learned, what I'm basically saying is we learned the rule if it's the same value for our degree over the same degree. So x over x, or x squared over x squared, we knew it was just going to the 5, 6. I'm saying you can take the derivative to see that as well. So the derivative of the top is 5. The derivative of the bottom is 6. So it's going to 5, 6. Right? Okay. So that's my third one. Make sure you can see. What if I say the limit as x approaches infinity of x to the 12th over natural log of x? Okay, so right now, if I put in infinity, it is infinity over infinity. That might be kind of hard to see. Basically, it's just going to keep growing on the top and growing on the bottom. So it is in the form infinity over infinity. So we can use our derivative rule, and we could say, okay, the derivative of the top is going to be what? 12x to the 11th. And the derivative on the bottom is 1 over x. Okay, if we flip that over, then we would have x over 1 times the 12x to the 11th. So that's going to give us 12x to the 12th. And then we can think of putting in that infinity. So now it's not infinity over infinity. What does it equal? Infinity. It's just going to keep growing and growing. Just think, I put in the number 2. It's big. 3, bigger. 4, bigger. 5, bigger. Is I put in numbers going to positive infinity. It's just going to get bigger and bigger. So it's going to infinity. Now that one, I don't think we did. Now the one before we did, but this doesn't, it's hard to know what the power would be for our rule, but basically the top's growing bigger than the bottom. So we're going to infinity. I know that from looking at it, but that might be a little harder for you to think of. Maybe not though. X to the 12th is huge. Natural log of X is not huge. So the top's getting bigger faster. Okay. Is it increasing, decreasing? Somehow my notes for the other section are mixed in here. Okay. Let's do one more kind of harder one. And then I think I'll call it quits. Okay, so the limit as x approaches 0 from the positive side of x times natural log of x to the power of 3,500. I think this is straight out of your homework. So right now, it is not in a form 0 over 0 or infinity over infinity. If I rewrote this to be natural log of x to the 3,500 over x to the -1. Weird, but I moved it down. Then it would be infinity over infinity. And that's really hard to see that. I don't think you would have thought of that step at all. So basically it is still in this rule. So we can take the derivative and put in our 0 from the positive side. Because right now we would get out 0, but you can't do the natural log of 0. Okay, so yeah, and we can't see that. Okay, so what can we do from here is do the derivative of the top and the derivative of the bottom. So this we would bring down out front. So we have 3,500 times 1 over x. That's going to be the top. So you have to bring the exponent out and then bring it down and then do the 1 over x. Okay, and then on the bottom, it's going to be negative x to the negative second. So you bring the negative 1 down, minus 1 more out of the exponent. Now let's rewrite this. This would be 3,500 over x over 1 over x squared, and that would be a negative 1. That's really what we have here. So we're going to flip this over and multiply and see what we have. So we're going to flip this over. So we have 3,500 over x times x squared over negative 1. And then we can see that one of these x's cancels with one of those x's, leaving just an x. And so we're going to have this x is going to be gone, and then that one will become an x. So we're going to have 3,500x, and it's going to be negative in order to cover that negative 1 there. Okay, so that's where we're at. Now, if we do the limit as x approaches from the positive side of negative 3,500x, we're going to put in that 0 and get out 0. But you're coming from the positive side. Maybe we should do our little chart just because. So what is on the positive side of 0? 0.1, 0.01, 0.001. And so we're going to put those values in, and we're going to get 0.1 times negative 3,500 is negative 350. Okay, and then negative 3,500 times 0.01, not sure why I need a calculator, negative 35. This one's going to go to negative 3.5. So you're just going to lose a decimal. Sorry. You lose a decimal each time as you get closer and closer to 0. So it's just approaching 0. Negative 0, but you can't have negative 0. That's a little, I don't know if I love that one. It's on your homework. I wanted to see one where you had to do some fractions and some stuff. Most of the ones that you're going to have are going to be more basic, and especially on the exam. It'll be, can you remember to take the derivative of the top and bottom when you're in this infinity over infinity or 0 over 0 form, and then to put your value in for your limit. Okay? And note, you can do, this rule is valid coming from the left, coming from the right, approaching infinity, approaching negative infinity, and yeah, I think that covers them all. So you can use this rule no matter what your actual x value is going to, negative, positive, so forth. All right.